Okay, welcome everybody. I'm Sébastien Deleuze, I'm a Spring Framework committer, and I'm also responsible for the Kotlin support of the Value Spring project. And today we are going to do a deep dive into Reactive Spring with Coroutines and Kotlin Flow. So we are going to see a wide range of topics, Spring Boot Kotlin support, what are coroutines, what are the new part of the Reactive Spring stack like R2DBC for Reactive SQL and RSocket. So we are going to see all these topics in details. We are going to start by a presentation. So the first part, 1 hour or 1 hour and a half, will be a presentation about why Kotlin is interesting to build an application on the JVM, especially with Spring Boot. We will see a status of the Kotlin support in Spring because in Spring Framework 5.2 and Spring Boot 2.2 we have provided various new features, so I would like to share that with you. We are going to talk about Reactive in general, R2DBC, RSocket, and what are coroutines and what is the coroutines official support that is coming with Spring. We will have a big break because I know that's a very, that's a lot of time. And in the part 2, we are going to build an application with all this thing with various steps. So we are going to start building an application with Spring WebFlux and R2DBC with the Coroutines API. We are going to have a look to the Router DSL and the functional API as well. We will introduce RSocket support. We will develop the front-end not with JavaScript or TypeScript, but with Kotlin JS. And that will be for us the opportunity to have a look to the Kotlin multiplatform support. So we will share some code between backend and front-end. And we will finish by an experimental project I have launched last year, which is Spring Foo, which contains Kofu DSL, which is basically explicit configuration for Spring Boot via a Kotlin DSL. So part 1 presentation, part 2 developing such application. And I would like to start by asking why should we use Kotlin to develop an application, because obviously a lot of developers, the majority of developers are using Java with Spring Boot to develop applications. But I think Kotlin, which is currently mainly used on Android side, could bring a lot of added value for server-side developers as well. Who has already developed? Raise your hand, please, if you have already developed an application with Kotlin. Okay, half of the room, I guess. So this is my reasons. Maybe yours could be different, and maybe you will agree or disagree with what I say. But my first reason is to improve the signals to noise ratio of your code. Our code is to express our ISDs, to implement our algorithm. We have to maintain that, and being able to write concise code that is written quickly and is readable and understandable easily is super important. And I think while working with Java, sometimes we forget a little about that. So I really think improving the signals to noise ratio is a big reason to use Kotlin. The second reason is safety, and especially null safety. So in Java world, we have this issue with null safety, which is usually called the billion-dollar mistake. I think it's much more, but let's call it the billion-dollar mistake, because null is not something which is specified explicitly in Java type system. Okay? I really think null is not an issue by itself, but when you have this thing which is implicit, you have issues like you have in dynamic languages. It's unspecified, and that can produce a null pointer exception at runtime. In Kotlin, we still have null, and we leverage that by dealing with null safety explicitly on the type system. So when you have a type, you specify if it's nullable or not. You still have to deal with null safety, but at compile time. So if you forget to deal with null safety, your compiler will raise an error instead of waiting production to raise a null pointer exception at the worst point. Discoverability is also very important, and Kotlin with its DSLs allow basically you to discover various APIs via autocomplete, and I think that's a pretty important to to be able to discover the new APIs that are coming with a new version of your favorite library, for example. And the DSLs are, it's still code, so you have autocomplete and it's valid Kotlin code, but at the same time it looks like a document. So it's like a good trade-off between code and documents with schema validation, basically, and everything in your IDE. Pleasure, I think that's a very important, and that's maybe the most important reason for me to work on Kotlin. I mean, nobody asked me to introduce Kotlin support in Spring. I just like this language. I think that's a good fit with server-side development, and I have a lot of pleasure expressing my ideas with that language. And I think before working with Kotlin, I mean, I was talking with people liking Ruby or thinking languages like that. And they were super passionate about the language. And I like Java, but honestly, I have much more pleasure developing with Kotlin. And we spend so many time developing code. I think that's a pretty important thing. The Android community has switched from Java to Kotlin in a very short amount of time. I think nowadays the majority of Android applications are developed in Kotlin. Android is now Kotlin first, so that means that Google is developing features for Kotlin first, and then it's available for Java. On server side, we are still Java first, and we will remain it, I think. I don't think Kotlin, at least short term or middle term, will beat Java. But I think the fact that a huge number of Android developers are coming learning Kotlin will have an impact on server side as well. And in the JVM community, we had basically Java and all the other language, alternative language, Groovy, Scala, Kotlin, etc. And I think now we are in an ecosystem where we have Java first, Kotlin second, and then the other languages. And that's pretty new because, yeah, that never happened. The multi-platform aspect is important. I think it is still the early days of that. But I really think there is a lot of values. So Kotlin has first-class support for the JVM, but it has also support for other platforms. So Android is it's also the JVM, but it's also different. And maybe in the future, it will be even more different than regular JVM we do on server side. Kotlin can also be used to develop front-end applications. So we are going to see later that we can develop front-end application with Kotlin. I am not here to sell anything. So honestly, developing a front-end with Kotlin, it's still the early days. There is a lot of things to improve, and I keep providing feedback to JetBrains and the Kotlin team, pointing, because I'm also a front-end developer, so I'm not just a server-side guy. I like JavaScript. I even created a small JavaScript framework a long time ago. But I really think Kotlin and TypeScript, for example, have some common points. I really think we could have a lot of added value using the same language for various targets, sharing some code, sharing some validation logic. So even if that's maybe not 100% usable nowadays, if I had to do a front-end application, maybe I would choose TypeScript today. But it begins to be more and more usable. And with platforms like WebAssembly on the radar, which is a kind of bytecode for the web, I think it could be really interesting to use Kotlin for front-end as well. There is also native support. It's mainly created for iOS support. Don't expect to do, I mean, you can create some kind of server-side application, but I think GraalVM with Kotlin JVM is more suitable for that kind of use case. But still, you have a platform which allows to develop application in Kotlin and compile it to native via an LLVM toolchain. So Spring loves Kotlin, and I'm going to explain how much. So we love Kotlin as much as we translated all the Spring Framework reference documentation from Java to Kotlin. So basically what I did was to take every single code sample in the Spring Framework reference documentation, and I translated it to Kotlin when there is some specific DSL or extension available for the Kotlin code, it is used. So it's not just an automated translation, it's also a way to provide you guidelines about how to write idiomatic code for your Spring Boot application with Kotlin. So if you go to the Spring Framework 5.2 documentation, you will see an additional tab for every code sample. You can switch from Java to Kotlin. When you switch to Kotlin, the switch is active for every code sample available. And if you are going away and coming back after that to the documentation, it's persistent. So doing that was a pretty extensive, important effort. So I had only the time to do it for Spring Framework, okay? But other Spring projects will also get their documentation translated to Kotlin. So Spring Boot 2.3 next year will have its documentation translated to Kotlin. For Spring Data is composed by 17 projects, so it's a lot of work. So I don't promise that we will translate everything, and I'm also not the Spring Data project lead, so I can't promise you that. But we have discussed with Mark Palush and the Spring Data team, and we will try to get some part of Spring Data documentation translated. My hope is that we would get Spring Data Common, Spring Data GPA, and Spring Data R2DBC documentation translated to Kotlin next year. No promise, but that's our goal. And Spring Security documentation will be translated to Kotlin. I will talk again about Spring Security just after that. So for Spring Boot, new feature, I mean, we did that change a few months ago, but when you are going to start.spring.io to create a new Spring Boot project with Kotlin, and if you select Gradle, we will automatically use the Gradle Kotlin DSL. So a few years ago, Gradle announced that in addition to the Groovy DSL, which is used to write your build.gradle, they will provide also a way to write your Gradle build with Kotlin instead of Groovy. The advantages are that in addition to just changing the language, they did a huge amount of refactoring to make everything more statically typed. Because originally, the Groovy DSL is, you can do static type with Groovy, but the Gradle DSL is developed in a very dynamic fashion. So they had a huge amount of work to make everything more statically typed. And the advantage for you is to have a better autocomplete. Gradle is a very powerful tool, but I don't know how you work with Gradle, but myself, with the Groovy DSL, I just take some example on internet and modify them, and hopefully that works. With the Kotlin DSL, I am able to use autocomplete. I'm lazy, so I really like to use the autocomplete, check everything which is available, and just write my code like that. So it brings some kind of structure to Gradle build file, and I really think that's a very good thing. And I think that also triggered some improvement on the Groovy DSL side, so that's interesting. This DSL has some drawback. Again, I'm not here to say everything is perfect. So the biggest drawback of the Gradle Kotlin DSL is that currently it's a little bit slow in the IDE. If you are using it and you are trying to have autocomplete, it's much slower than on Groovy I don't really use the autocomplete, but it's slower than that, for example, using autocomplete in regular Kotlin file. The Gradle team is aware of the issue. They are working hard to improve that. And in the next version of Kotlin, 1.3.60, the performance of the autocomplete will be much faster, I think twice faster. So they are working hard on the issue. But yeah, if you use autocomplete and if you change your Gradle build file, you will see that there is a lot of CPU cycle recompiling everything, and the autocomplete is slow. Hopefully it will get better and better. We don't provide a choice, so by default, if you use Gradle and Kotlin, the Gradle Kotlin DSL will be used by default. If you are creating a Java project and you want to use this Gradle Kotlin DSL, it's not possible yet. Feel free to ask that on the issue tracker, but for now, we don't want to provide too much checkbox, so we provide this opinionated choice. if you use Gradle and Kotlin, we will use this DSL. Otherwise, we will just use the Groovy DSL. Configuration properties. That was painful before with Spring Boot 2.1 when you were writing at configuration properties in Kotlin. If you want to write this in a kind of idiomatic way, you want to use with Kotlin immutable, data classes with immutable properties. Okay, but it's not possible because Spring Boot comes from the Java world, and in Java world, immutable data structure are not first-class citizen. And you had to use this kind of late-init var construct, which is not super idiomatic. And I was crying every time I was writing a Spring Boot application in Kotlin. So after talking a lot with the Spring Boot team, they provided this new feature in Spring Boot 2.2, which is also available in Java. So with Spring Boot 2.2, you can create immutable configuration property classes. And it supports data classes with immutable properties. You have to use this add constructor binding for various technical reasons. I had a lot of discussion with the Spring Boot team, and it was not possible to support it without this add constructor binding. Maybe in the future version with Kotlin, we will be able to say, okay, if it's a Kotlin data class with immutable properties, then add constructor binding could be implied. But for now, you have to specify explicitly to be able to use this kind of structure. And the good thing is that we can just use Kotlin idiomatic code with Spring Boot 2.2. Start.spring.io also help you to share a Kotlin project because basically you have a new share button that allow you to share customized configuration. So you go to start.spring.io, you select Gradle, Kotlin, every kind of dependencies, and you can basically get a customized URL that will bring you or other people to this customized start.spring.io configuration. You will have also the form which is filled with what you selected. There is also more DSLs. So we try to be careful and to not create too many DSLs because with Kotlin features like DSLs or extensions, it's tempting to create extensions and DSL for everything. So we try to limit ourselves to where that really makes sense. And Spring Security is a very good use case because Spring Security has a DSL to configure the security in Java, which is pretty extensive. It was also created before Lambdas, so it's clear that with Kotlin capabilities, we can express the same thing in a more concise and readable way. And I'm super happy that this Spring Security DSL is coming from Spring Security team, so I have nothing to do with that. And Stein from Spring Security team, which is managed by Rob Winch, has created a dedicated DSL which allows to configure everything in Spring Security with the Kotlin DSL. So this is not a community project. This is really first-class support. For now, it lives in github.com/Spring Project Experimental. We will mature it this year until next year, and next year it should be integrated directly with Spring Security 5.3. Okay? So for now, I don't remember if the first release has been published, but it's about to be available. So it will be available in experimental mode. You can use it, but we will maybe change a little bit the API, refine. So feel free to try it and provide feedbacks. And it's likely it will be integrated in Spring Security 5.3. And remember, just previously, I talked about the reference documentation. So Spring Security reference documentation will directly show in its Kotlin code samples how to configure it using this DSL. This is a little bit out of topic, given the fact that today we are going to talk about reactive and coroutines, but I would like to highlight that because the DSL is very similar to the coroutine one, and also this has been asked by a lot of people, so I would like to take just a few minutes to talk about the Spring MVC DSL and the functional API that are available with Spring Framework 5.2. So, you have, with Spring Framework 5, you add two ways to write your your web endpoint. You can use add controller and add request mapping. This is the usual model everybody knows, but it is also possible to use the Kotlin DSL. It was previously available only for WebFlux, and the idea is that with Spring Framework 5.2, it's available for WebMVC as well, for Spring MVC basically. So you can use it with Tomcat and Servlet underneath. So you have basically, you create your endpoint by creating a handler function that take as input parameter a server request and return a server response. In terms of implementation, you have various static methods available in server response that allow you to specify the status code. You can provide the body. You can specify any kind of headers, okay, via this kind of API. And you will plug this handler into a router, which will specify the mapping. Usually, we are using callable references, like here with hello, to make the link between the router and the handler. You can then expose the router to Spring Boot. So to expose the router, you just have to publish a router function bin, which will be automatically used by Spring Boot, and your endpoint will be available. If we are writing a more realistic example, what you will do is basically creating a handler class annotated with add components. You will inject, for example, a repository or a service. In Kotlin, we really favor constructor-based injection. I mean, in Java, we try to favor it, but a lot of people still are using other kind of injection. In Kotlin, it's almost mandatory because the language is really designed for read-only properties to use this kind of private val repository and the type. And remember that by default properties in Kotlin are public. So here I'm specifying private because there is no sense to expose this repository in the public API. If we are having a look to a more realistic handler, you can a more realistic router. You can see that here I'm specifying that for every JSON media type, /person, /id, and /person will be forwarded to the related routers. You can write any kind of request predicates. You can combine them. You can nest them. You can specify condition on headers, and you can even write your own request predicates. So it's much more flexible than the annotation programming model, and you can write your tree of routes like that. And it's much more than syntactic sugar because you can create routes dynamically. Obviously, you need to take care of caching and things like that, but where annotations are basically statically defined, with the router, you can create routes dynamically. For example, when you start the application, even when you receive a request. So if you are building some kind of CMS or e-commerce software where the routes are defined dynamically in your database, it's possible to handle that with this kind of routes, where with annotation, you are basically in big trouble. I provide another status table because there is a lot of features. So to make it clear what is supported with Spring Boot 2.2, we support the beans DSL, the WebFlux Router DSL, the coroutine router DSL that we are going to see later. There is this new WebMVC router DSL, and we have also a mock MVC DSL, which has been contributed by the community. And the Spring Security DSL is in experimental mode, and all these DSL will be supported in a production-ready fashion next year. So we are now going to talk about why reactive. So with Spring Framework 5, we introduced a new reactive stack in parallel of Spring MVC, Tomcat, which is more blocking style, to provide better scalability and efficiency typically, the Spring MVC and Tomcat stack is using a lot of threads. And with WebFlux, based on the native runtime, we are more scalable and more efficient. We try to break this HTTP exchange equals thread coupling by being able to process a lot of HTTP exchanges in parallel with just a few threads, and that's possible with less memory consumption. It's also possible with this kind of stack to be neutral to latency if you are building microservices, or if you are just, if you have to do some processing that involves some latency, like calling a remote endpoint that you don't control, which will be super slow because, I don't know, you have some customers on some partner that expose a very slow REST endpoint. That will basically make your application neutral to latency. I mean, the fact that the remote endpoint will take a lot of time to answer will not impact the scalability of the consumption of your own service. There is also back pressure, which is flow control to avoid overwhelming the consumer. So the idea with back pressure is that you deal with the demand. So instead of being overwhelmed by, when you are developing a slow consumer and you have a very fast producer, basically what's usually occurred without back pressure is that you have some kind of buffers that grow because you can't process all the data, and at some points your service crash because it does not have any memory available. With back pressure, with back pressure, it will be possible to limit the amount of in-flight data, and if you don't ask some data, you won't receive them, so you won't have this growing buffer issue. And that provides a better programming model for concurrency. And with the declarative approach you have in API like Flux, for example, it's much better for dealing with concurrency. And if you deal with streaming, like with server-sent events, or if you want to stream data between two microservices, that's also a very good use case. But that's not a free lunch, and using a reactive stack requires to change from imperative to declarative and using a dedicated stack. And I won't say, imperative is great, declarative is great. It depends on the use case. It's not that declarative is bad. I think for some use case, imperative code is great. For other use cases, declarative is great. And we are going to talk a lot about that in the upcoming slides. Spring Reactive Stack is based on Reactor, which is a reactive streams implementation. So in Spring Framework, Spring Security, Spring Boot, and Spring Data, every reactive feature is based on this Project Reactor foundation. And I'm now going to talk about R2DBC. Because when we have introduced this reactive stack, we have provided some support for persistence in Spring Data, but only for NoSQL solution. So reactive persistence support was available for MongoDB, Redis, Cassandra, but only for NoSQL. And people were asking, what should I do if I use SQL? So obviously, you can use a regular JDBC or GPA API into reactive application, but you need to take care about using a dedicated schedulers and basically creating a dedicated thread pool to execute all the persistent stuff. And that's not the way we want to push people to deal with that to persistence with our reactive stack. So we have worked a lot on R2DBC, which is basically reactive SQL. So R2DBC is a reactive SPI for SQL drivers, and it embraces reactive types and patterns. So in R2DBC API, you will see it will use a lot publishers. It's non-blocking all the way to the database. It's documented. It has documented specification. it provides various drivers, and we are going to see what drivers are supported. It shrinks the driver SPI, and that's important because JDBC JDBC is useful for database driver, and it also should be usable for end users. R2DBC don't try to do that. It really focuses on a very narrow, low-level API that should be implemented by drivers, and then it let open the choice for a more human API. It only depends on Java 8 and Reactive Streams, so there is no dependency on Reactor, for example, in the R2DBC SPI. In implementation for drivers that depend on Reactor, obviously they depend on Reactor, but the SPI is pure Java 8 and Reactive Streams. And since Java 9 includes Reactive Streams API, we can say that it's basically conceptually just Java 9 APIs used in the SPI. So what drivers are available in this Reactive SQL world? The first-party drivers are PostgreSQL, Microsoft SQL Server, and H2 database. And developed by the community, there is MySQL. So we have two drivers for MySQL, SAP HANA and Google Cloud Spanner. And we have various database vendors that are contacting us for R2DBC support. So this list is going to grow. In terms of clients, by clients, I mean how do you use as a developer R2DBC? So the one that we are going to see today is Spring Data R2DBC. That's a Spring Data project that exposes you an API that allows you to deal with Reactive SQL. There is other ones. You see a lot of clients in development, and I have linked the various GitHub issues for this support. We are now going to talk about RSocket. So we have worked a lot on Reactive Streams, Reactor, even R2DBC, but it's all included in the JVM. So what happens when you are using a reactive stack when you want to communicate between two servers, for example? So until now, we provided some streaming support using server-sent events, even WebSocket, but that was not really propagating the back pressure across the network. And that's really what RSocket is providing. And yeah, I'm excited by R2DBC, but I'm super excited about RSocket. I really think that even with other programming model, and we are going to see that with coroutines, we can leverage RSocket semantics. That's a very interesting protocol. So that's basically reactive messaging that allows communication between two remote endpoints. And we are going to see the characteristics. So the first characteristic is that it does not require code generation. Okay, so you don't have to have code generation. You can build on top of RSocket some RPC system that imply code generation if you want to, and there is a few ones already available. But by default, you don't have to. We don't force people to do code generation because sometimes it's relevant to avoid that. The second point is that you have clients available in various languages and technologies. Okay, so RSocket is a specification written by clever people and pretty well written. So it's available for Java and Kotlin. The Java Kotlin client is written with Reactor, so that's also another reason why we like this protocol. But another client is available with JavaScript, C++, Go, .NET, Python. And yeah, again, I have already implemented some crappy specification. The RSocket one is really a pleasure to work with. Oh, and there is another point is that RSocket is independent of the transport. So you don't have to use a specific transport with RSocket. It's possible to use TCP directly if you are inside the firewall. You can use WebSocket. You can use, I think there is some HTTP2 support. So you have the choice of the transport, and it's pretty nice to be able to decouple what you are using in terms of protocol for reactive messaging and the underneath transport used. It's possible that you have already used RSocket on your smartphone, for example, because there is some stakeholders like Facebook and other big companies. So even if you have maybe not heard a lot about that protocol, it's already used in various applications, especially between server-side and mobile applications, quite a lot. And you have all these companies that are one way or another working on this protocol, and it's now part of the Reactive Foundation. So that's a foundation about various reactive technologies, and RSocket is now part of this foundation. There is support of RSocket in this Spring project, so it's already available or it will come shortly. Spring Framework, Spring Security, Spring Boot, Spring Cloud Gateway, and Spring Integration, all based on Project Reactor. We are going to see more about RSocket protocol. So RSocket is an application protocol for multiplex duplex communication. So you can basically multiplex various connections into a single connection at transport level. And it's a two-way communication. So that's the duplex part. So if that reminds you WebSocket, that's true that WebSocket allows to do that, but WebSocket is super low level, while RSocket is more high level. It deals with back pressure, it deals with messages, so it's much more high level. And WebSocket is available as a transport to carry RSocket if you want to use it, for example, in the browser. So like I said, you have various transport available, and it's up to you to choose the most optimal one for your use case. So you have UDP, TCP, WebSocket, and other transport will come, and you have the choice. It provides 4 interaction models. The first one is request response. So in the request response interaction model, it's similar to what you have in HTTP. You will send a request, and you will get a response with the payload. Request stream is a little bit different. So you send a request, and you receive a stream. So it could be similar to what you have with server-sent events. Okay? But here, RSocket natively deals with various messages. You have request channel, which is basically creating a two-way channel for discussing between a client and a server, and you have bidirectional streams. You have request fire and forget. So here you are just sending something, and you don't care about is it received or not. So this is useful for very efficient communication. You want to of non-critical data. So you want to send a lot of logs, for example, or things like that. You don't care about is it received or not. You just push a lot of things. So that's a pretty powerful mechanism. Like I said, it's duplex, so you can use both ways communication. And in HTTP, you just have the client, which is the requester, and send something to the responder, which is the server, and then you get the answer. It's with RSocket, the server can be the requester and send some data and get some response. So that brings some new possibilities compared to HTTP. It implements reactive stream semantics, but not just inside the JVM, but on the network. So it deals with, for example, back pressure. So the protocol will send, for example, request and data, and then the responder will send just the number of data requested. And that's super important when you are using the network, because like I said, the issue that we want to try to avoid is to have buffer that grow and grow when we have a slow consumer and a very fast producer. So it's pretty interesting to have this back pressure managed at the network level. You have session stream resumption, and that's super important and super useful because that's natively supported by the protocol. So if you have some connectivity lost, and if you are developing some application that imply mobile phone, for example, you will have that all the time. The protocol will natively handle connectivity loss and just resume the connection where it was closed. So you will avoid duplicated or lost data. Okay, and you can resume, and it will resume exactly at the point where it lost the connection. And it requires some state management on server side, but not a lot because, again, with back pressure, we don't have to have huge buffer to store everything. So that's a very good fit with the back pressure management at network level. The back pressure is per stream by default. So you may ask, what about the total number of requests and stream? Since I have multiplex connection and I can have a lot of different channel opens, what if I want to basically deal with, I want to limit the total number of parallel requests and stream? That's what is called leasing in the protocol. So leasing is that, but managed for all the opened channels, and you can configure that you can configure request routing with lease with RSocket clients. Like usually for this kind of protocol, you have also fragmentation and reassembly and heartbeats to detect when a connection is closed. So this is, if you have already developed some application with a server-sent events or a WebSocket, this is all the kind of issues that you can have with this low-level protocol are here correctly and natively solved with RSocket. Okay, so we are now going to talk about coroutines. And we are going to begin talking about coroutines in general, and then we will focus on what that means for the Spring support. So coroutines are lightweight threads. I mean, you can create thousands of threads, but you can create hundreds of thousands of coroutines, because for one coroutines, you have a very small allocation, and you can create, I mean, basically you decouple the OS threads from the threads that you deal on your programming language side. The foundation are in Kotlin language, but there is a very small amount of things that are implemented at language side. Most of the implementation lives in the library side in kotlinx.coroutines, and that's pretty interesting because unlike other languages and technologies, it makes coroutines super flexible. So coroutines are interoperable with completable feature, Flux, Mono, every other kind of type. Where everything is hard-coded on the language, it's usually not possible. Also, when you talk about coroutines with somebody, or when you think yourself about coroutines, think about what that means. Because when you say the word coroutines in Kotlin context, you could talk about the library, about the language feature, about this lightweight thread. So sometimes there is some confusion about coroutine because two people don't talk about the same thing. So maybe explicit what you are saying or referring to when you say coroutines. And coroutines allow to consume Spring Reactive Stack with a nice balance between imperative and declarative style. So it's not all about being imperative. I will show you that. It's a nice balance between both. And in my opinion, that's a perfect balance between both approaches. Operations are sequential by default, and that's different from what we have on reactive side. Concurrency is explicit, so concurrency is possible. There is a wide range of features to deal with that, but you have to explicitly say that here I want to do things concurrently. And there is three main blocks that you need to know. There is more APIs and things in coroutine, but if you need to learn just something, I think knowing where these three building blocks is super important. The first building block is suspending function. So a suspending function is a Kotlin function where you will add this suspend keyword before the fun keyword. and that will explicit that this function is a suspending one, and so it will run on coroutine. So when you add this suspend keyword, that means it can run as a lightweight thread, as a coroutine. A suspending function can call and invoke other suspending function. So here, delay, which will basically not block but suspend the execution of the function during 1 second, it's a suspending function. Okay, and typically when you are using an HTTP client that will request a remote web service, when you are going to request your database, these are all operations that imply some latency, and then you will use suspending function. Suspending function color your API, and I think that's not a bad thing, but that's a characteristic you need to keep in mind. There is a difference between suspending and non-suspending function. Okay, so for example, if you are using Mono or Flux, there is regular API and there is reactive API that deal with Flux and Mono. With coroutines, the fact that a function can be a suspending function, it's explicit, and you can't call a suspending function from a non-suspending function. Okay. The second building block is structure concurrency. So when you are dealing with asynchronicity with imperative code, you need to have some kind of building block because the asynchronous nature implies some specific concern. So in this example, we have this load and combine function, and we define a coroutine scope which includes launching two asynchronous operations in parallel. So we load the image 1 and we load the image 2. And what happens if you have an error in one of these functions? You need to define that, for example, when you have an error when loading image 1, you want to cancel image 2. And that's what structure concurrency allows. Here we define a coroutine scope. It's like a transaction, for example. We define just a scope to define that when image 1 or image 2 loading through an error, you have to cancel the other asynchronous operation. Okay? So think about it like a transaction, but for this asynchronicity topic. The third building block is flow. So they choose the same name than the Java 9 flow, which is the type that includes reactive streams interfaces in Java 9, but that's a totally different beast. So when I will refer in this talk about flow, I'm talking about kotlinx.coroutine.flow.flow, not the java.util.concurrent.flow one. So this flow type was not available in coroutine last year. And it is now available as a non-experimental API since coroutine 1.3 that was released a few weeks ago. You can think to flow like the equivalent of Flux in reactive world, but for coroutines. And flow is interoperable with reactive streams and support back pressure. So in terms of API, we have this, in coroutines library, we have this flow type, which is a generic type. And in terms of design, it's interesting because it contains mainly one single suspending collect function, okay, which itself contains a flow, use a flow collector parameter that contains a suspending function that can emit values. And since Kotlin provides extensions, you know, with Flux or Flowable API in generic Java, you have this 1,000 operators directly available in the type. Here, a flow is a very narrow API, and all the operators are provided as extensions. Okay, that means that the operator like filter, map, zip, provided by the coroutines library, are available as extensions. And that means also that you can write your own operator as extension as well. So here I have shown the implementation of the filter operator. And another difference compared to reactive API is that operators are pretty simple to implement when they don't imply concurrency. I don't say every operator is simple to implement, but in reactive world, if you want to implement a reactive operator, it's super hard, and you have to be David Kernok or Stefan Maldini to be able to do that. In coroutines world, custom operators are doable by everybody when they don't imply concurrency. Operators with concurrency are more complex. So here we have an example of the filter operator defined as an extension function. So extension function adds a new function on existing type. Okay, and here we are adding a filter function in the flow type, and we provide its implementation, and that's a filter operator provided with coroutines. I have just taken the source code from the library, so you can see the implementation is pretty simple. When you want to create a flow, you will use this flow builder. So we create a flow and we provide a lambda. And it's funny because it's imperative code. So here we are just creating a for loop. We are calling this delay method to simulate some kind of operation with latency. So in real life, you will, for example, request a remote REST endpoint. And in coroutines world, it's perfectly fine to suspend. Okay, blocking in reactive world is bad, but suspending in coroutine world is perfectly fine. So you will just simulate some remote operation and then emit the data. And that's all. So that's pretty interesting to be able to write reactive code which back pressure with this kind of imperative code. In my code samples, I have highlighted the extensions in yellow to make that more easily understandable. So here, when you consume a flow, it will be more a declarative approach. You will type flow.filter. You specify the condition. So you will just you will filter all the data where it is less than 2. Then you have map operation. You have zip. You have all the not all. You have some of the operators that you have in reactive world. Flow is a pretty young type, so don't expect to have all the Reactor and Aric Java operators, but it will get better and better. And you can call collect to trigger basically the processing of the data. An interesting difference compared to reactive world is that you can do asynchronous operation in map. Where you are using a Reactor API and you want to do some asynchronous operation that return a mono, you have to use flat map to flatten the mono inside the flux. In coroutines world, the various operators like map take a suspending lambda as parameters. That means that you are allowed to call any suspending function in any operator. And that's why in map, I can, for example, call any kind of asynchronous operation. I don't have to use flat map for that. Flat map is just to flatten a flow to another flow. And that's something that leads to simpler code. So what about the Spring support for coroutines? So we have this Reactive Spring infrastructure, which is based on Reactor. And what I want to show with this diagram is that Reactor is used for two different purposes in our stack. It's the reactive foundation, so all the internals based on reactive streams are implemented with Reactor, Flux and Mono, schedulers, etc. And when you will, whatever asynchronous API you will use, underneath this Reactor, reactive architecture is used. But for the API that you are using in your application, you have the choice. With our annotation programming model, it's super easy for us to support various APIs because basically we just have to support the type that you are using in your as a return value or in parameters of your @request mapping endpoint, for example. So here we are supporting out of the box mono and flux, single maybe flowable from RX Java, completable future, publisher. If you are using that as a parameter or return value for your request mapping, for example, or in Spring Data, we will support that, and we will translate that automatically into reactive streams and use it with Reactive Spring infrastructure. In terms of API like WebClient, for example, the API that we provide for the reactive HTTP client, or this kind of API where we provide an opinionated API, until now, until Mono and Flux were supported. So what Spring Framework 5.2 and Spring Boot 2.2 brings is coroutines-based API for both options, and we are going to see how we have provided that. So how Reactor API translate to coroutines when you add a function that was returning mono of void. In coroutines world, that's just a suspending function that return a unit, basically, so you don't have to return anything. A handler that was returning a mono of t will just be a suspending function that returns t. And that's a little bit similar to null safety, where you don't have to use optional in Kotlin. Here, I like the fact that you are just dealing with regular types without any kind of wrapper when you are just dealing with single value or no value. Okay? And when you deal with Flux, the corresponding thing in coroutines world is flow, like I have shown previously. So Spring provides official coroutine support for Spring WebFlux, Spring Data, Vault, and RSocket. For Spring Data, we support Redis, MongoDB, Cassandra, and R2DBC. So how we support that in WebFlux? So no new types were introduced. Okay, so you are still going to use WebClient or other types that you are going on the reactive side. But and we support seamless support with the ingestion programming model. We provide context interoperability between coroutines and Reactor. So in reactive world, we can't use thread locals, for example, to deal with transaction or security, because we can't rely on that in reactive world. That does not make any sense, because multiple requests will be processed potentially by the same threads, and we can't do that. So to deal with transaction and security in reactive world, we leverage Reactor context, which is basically a kind of hash map linked to the reactive pipeline. And the interesting thing is that coroutines has also a context, which is coroutines context. And what JetBrains has done is that the coroutines context and Reactor context are automatically interoperable. That means that when you put something on coroutine context, it will be available, for example, at the framework level on Reactor context, and in the other way as well. And that allows to support reactive transaction and security in coroutines world. I will show that later with the application we will develop. So what that look like? So if you want to use coroutines, the support is not available in Spring MVC. You have to use Spring WebFlux. The support in Spring MVC will come likely next year. But for now, we are really talking about leveraging WebFlux. And instead of returning some things, a mono of a banner, we will just return a banner with this suspend keyword, and the internal processing will be asynchronous. It's also possible to deal with view rendering. So same thing, you are just using, the code is very similar to what you would have written for a regular Spring MVC application, except that here you are using this suspend keyword. So we provide reactive type extension for coroutines API, and that's how we can support coroutines without introducing new types. So, for example, we have this WebClient type, which provides a reactive API to deal with remote HTTP endpoints. And in addition to the body to flux method that you have currently, we provide an extension which is body to flow. We have also extension like await something to provide suspending functions that are the equivalent of body to mono, and that allow you to provide seamless coroutine support without introducing new type. There is also some support on WebFlux Router side. So here again, we have added extensions like body value and await that allow you to write imperative code where you are dealing with single values. For RSocket, and we are going to see all these API in the application we are going to develop in the second part of the presentation. We are using this RSocket requester, which is basically WebClient equivalent for RSocket. And in addition to the retrieve flux method, we have added this retrieve flow extension that make it possible to use any kind of flow operator in your application. And we support coroutines return type. That means that you can return a flow or return or create a suspending function. It will work as expected. There is support on Spring Data R2DBC with transaction, and again, we are going to see that in the application we will develop. But in a nutshell, the database client is the API that we are using to request the database with some SQL requests. It supports, so we provide extension on R2DBC database client API, like await, and we provide also functional transaction support, which is this execute and await, where you define the scope of the reactive transaction that we want to define. It's also available for Spring Data MongoDB. So basically, the idea is that we provide coroutine extensions on top of reactive types, where that matters. So here we have added coroutine extensions on top of reactive Fluent Mongo operations, which is a pretty long name, but that's what it is. And you see that for suspending function, by convention, we are usually using this word await that identifies the suspending extensions. And for flow, it's just a word flow. So coroutines are now the default way to go reactive, so that's perfectly fine if you are creating a Kotlin application and you want to use reactive API like you were doing previously. But since people are asking some opinions and since we need to simplify the choice, by default, we provide the coroutines dependency on start.spring.io. That means that if you start a new Kotlin project with some reactive stuff with start.spring.io, the coroutines dependency will be automatically added to your Gradle or Maven build file. And in the documentation, by default, it's coroutines code that is shown in the reference documentation. Again, a new table with the status of the supports. So in Spring Boot 2.2, we support, in terms of coroutine support, we have Spring WebFlux functional APIs, Spring WebFlux web client, Spring WebFlux at request mapping, RSocket at message mapping. We are going to see that a little bit later. Spring Data Reactive API and functional transactions. What is not supported yet is Spring MVC at request mapping, because I don't know if you are aware of that, but Spring MVC is not as powerful as Spring WebFlux, but it provides some support for mono and flux. So in theory, it should be possible to support coroutines, and that will be the case, but next year. Spring Data repositories, so when you are creating some at repository classes with a find by name, etc., it's not supported yet with Spring Data reactive support. And transactions defined by annotation with @transactional are not supported yet. So for now, you will have to use the functional transactions. Okay, so I think it's time for a break. We are going to see in the second part of the presentation Spring Messenger, which is an application that we will develop in 5 steps. The first step will be creating Spring WebFlux. We will be using Spring WebFlux and R2DBC for developing basically a REST server, which is using Spring Data R2DBC for the persistence. Second part, we will translate the application, which is using @request mapping and @controller with the functional router. Then we will introduce RSocket, Kotlin JS, and we will finally use the Kofu DSL to configure the application. So basically, that will be this kind of architecture. We will have a backend with a SQL database used with Spring R2DBC. You will have communication between a bot and the backend with RSocket with TCP connection. And we will use server-sent events to discuss with the Kotlin.js frontend. So yeah, have a break, and in 30 minutes, we will begin developing this application. Thanks. Okay, we are going to start the second part of the presentation. So, like I said at the beginning, we are going to develop a Spring Messenger web app, which will be composed by a backend developed in Kotlin with Spring Boot 2.2. It will use a database with R2DBC, so with this kind of Reactive SQL API. It will discuss with the bot, which basically will just send some messages via RSocket using TCP transport. And the exchange between the backend and the frontend will be done via server-sent events. Ideally, I would use RSocket JS for that. But for various reasons, I will explain you, it was not possible to do it right now, mainly because the RSocket JS library was not using some extensions that we have added for the routing. And also it's a pretty young library. On server side, it's quite robust. On front end, it was too complicated. And also, I prefer to use Kotlin.js, so to show you the usage of coroutine on front end, I prefer to use server-sent events. It was simple, but ideally, if next year I will do the same talk, I will use RSocket.js. And if you are using a TypeScript or JavaScript, you can totally use RSocket from the browser. You just need the upcoming release that will support the routing metadata extension. So we are going to see this application. Okay. So I will show you, we are going to see 5 versions, so 5 branches of this application. Originally, I was planning to do it full live coding, but somebody stole my laptop 2 weeks ago. So I had some, I was pretty short on time, so I will do it the safe way. Hopefully that will be great for you as well, but just to explain you what happened. So we have this application, which is a Spring Boot 1. So you see we have this build.gradle.kts. In fact, in your regular process, you will go to start.spring.io. Okay. We have a very nice dark UI mode. And you will select Gradle, you will select Kotlin. And an interesting feature, so you can see that we have RSocket support. Okay, here we can add Spring Reactive Web, etc. And we have this nice Explore feature that basically generates, instead of generating the zip and you have to download it, extract it, and in your IDE, if you want just to take some part, you can just explore, copy and paste. I think that's a pretty handy new feature that allow you to just take what is needed without having to create the archive. So let's say we have created this project. So you have this build.gradle.kts, which is natively supported by IntelliJ IDE. I'm not sure what is the support currently in Eclipse, but generally, for now, I really advise you to use IntelliJ IDE. I push with Kotlin team. I really try to make the Kotlin support on Eclipse better, but it takes some time. So for now, really using IntelliJ IDE is almost mandatory. So we are using the new Gradle syntax to declare plugins, and that's especially important with the Gradle Kotlin DSL because that's what will provide you autocomplete. So you can't use the old way with where you declare directly the dependency and you apply the plugin. That does not work very well with the Gradle Kotlin DSL. It looks like the Groovy DSL, but everything is more statically typed. If I ask some autocomplete, you will have the various capabilities provided here. And that's just a regular Gradle build file. You declare the dependency. So here we are going to use Mustache for the templating. We are going to use WebFlux. We are going to use Spring Boot data R2DBC. So Spring Boot starter data R2DBC is still experimental. It's you can find it if I go to Spring projects. Experimental. Okay, R2DBC. So it's available here. Okay, it's not yet 1.0, so it's still the auto configuration still live in this project for now. We are using H2 locally, but in production, or if you are using locally a Docker container, you are likely to use PostgreSQL, for example. The Jackson Kotlin module is automatically added by start.spring.io, as well as the Kotlin X coroutines reactor dependency, because we are going to use coroutines. So like I said, in start.spring.io, if you use Kotlin and you are using some reactive dependency, if you have a look to the Gradle build file, the dependency is automatically added, so you don't have to do it yourself. So back in the code. So we have this backend application. So for the main class, it's just messenger application. It's annotated with @Spring Boot application, and Spring Boot provide a run application, which is the equivalent of Spring, the Spring application.run static method, and it allows to start your application. Notice that it's not just syntax sugar. You can also have access to various ways of customizing your Spring Boot application if you add a Lambda here. Okay, so you can specify various things, like if you don't want to display the banner or crazy things like that. Okay, we have the model. So here we are using a very simple model with data classes with read-only properties, like it is usually the case with idiomatic Kotlin code. Message, user, very simple. And then we have a user repository. This user repository is using database client. So database client is the functional API to deal with Reactive SQL through Spring Data R2DBC. It's designed a little bit like WebClient for the HTTP side, but here we are going to request a Reactive SQL database with a Reactive API. And it's a lower level abstraction than GPA. You don't have all the mapping, object mapping side, okay? So that's really low level. You are directly writing SQL code. So if you want to use a specific feature of your database, you can. So you can use specific feature. For example, PostgreSQL has great JSON support. Or if you are using some special extension, for example, for your database, this is not an issue here. And Spring Data R2DBC provide you this Fluent API. So here I specify if I want to perform a select operation, or if I want to do insert, or if I want to execute any kind of SQL code. I specify, so I can show you with the autocomplete, so you can choose what you want here. Then you can specify the table. You specify the type of the return result. Okay, so it will do some kind of basic mapping well-known type to your object, and then you fetch the data. And here we have access to, so all by default is a way to retrieve a flux. That's why what is available in the API. And flow is an extension. So if I go to the code, you will see that flow is an extension that we had on Rose Fetch Spec, which is a class of the Fluent API. And you see, in fact, we just take all, which is the original method that return flux, and we transfer it, we convert it, we adapt it to flow. And that's a very lightweight operation. So flow and flux share this kind of reactive stream style, reactive stream semantics. So it's really easy to transform one type to the other. Okay. If we have a look to find one, this is a suspending method. So in reactive world, we would have returned mono of user, but here we are just returning something, a plain user. So in a way, we are able to write reactive codes in a more imperative way with a style which is closer to what we are used to. And so we specify the SQL request. We bind the login parameter. So here, it would have been possible for me to use a string interpolation, okay? Because Kotlin provides this kind of nice feature. But for security reasons, to avoid SQL injection, I prefer to use the binding capabilities provided in the database client API. I specify the return type, fetch, and here I have various extensions. So still, if I'm going to through the code, here I'm just using one which return a mono, and I'm using an extension that turns it into a suspended return value. And the IDE does a pretty good job to provide autocomplete for extensions. So in terms of discoverability, that should be okay. Here, so unit in Kotlin is like void in Java. Okay. So here, this return nothing. And the API is again closer to what we used to have in the imperative world. For the initialization, I'm defining an event listener on the application ready event. And here I'm creating a reactive transaction. So there is no support for add transactional yet, so you can't use that for now. It will be available next year, but it was more work for us and it was not possible. But conceptually, you can do exactly the same by injecting a transactional operator, which is a type which provides reactive transaction management. And what I have done is that I have just added some coroutines variants. So here, execute and await. I'm still using the await prefix or an await suffix convention to identify these suspending extensions. And inside, I execute my operation. You can see that the IDE indicates when we are calling suspending methods via this little icon. And everything, if I have an error in one of these statements, everything will be rolled back. It's transaction like we are used to, but in reactive world. Again, add transactional will be available next year. So here, that's just another way to express the same semantic. If you are using the Spring Boot R2DBC support, transactional operator bin will be automatically available. We use constructor-based injection like it is advised in Kotlin best practices. Since my class has a single constructor, it will be automatically auto-wired. I don't have to add. I mean, if it was not the case, I would have to add auto-wired constructor, but here I don't have to do that because that is implicitly done because there is just a single constructor. Notice that transactions are available for suspending functions. So here in this lambda, everything will be transactional, but there is also a transactional operator here. So everything, if I use this transactional operator, every Spring Data R2DBC operation done inside the operators of this reactive type will be part of the transaction. Okay, so this is available in imperative way for suspending function, and this is available as an extension for a flow type. And again, how we do that via an extension, because obviously the flow type, which is coming from the Coroutines library, does not provide any kind of Spring transactional support. So we are using an extension to provide it like that, and it's much more readable than a static method, for example. Then we have the web part. So we have a user controller. Again, what is interesting with coroutines is that your code is much closer to what you write with Spring MVC, which is a model that everybody knows. You notice that when you return flow, you don't have to make the method suspending. It's possible, but you don't have to, because the suspending operation will be done inside the operators. Okay? Think about, conceptually, adding suspend keyword is like wrapping your return result into mono or completable future. Okay? So here, I don't have to wrap my flow into something because asynchronous boundaries are inside the operators, where here, I see I'm returning a user. So in reactive world, I will use a mono of user, or with asynchronous Java API, a completable future of user. So here, I'm just using the suspend keyword with a user return value. Maybe a quick tip about how to, by default, IntelliJ IDEA doesn't show you the inferred return type, because in Java, we write explicit types everywhere. In Kotlin, we have the choice to write it or not, so I could write user myself, but I usually prefer, at least at my taste, to leverage Kotlin great type inference to implicitly have this type inferred. But by default, it is, I think it's not displayed by IntelliJ IDEA, so you can configure it by going to, and that's a long journey, so be prepared. You go to Editor, Appearance, Show Parameter Ints, Configure, Kotlin, and then you, so this is my configuration, show function return type ints. That's the one which is pretty useful and not configured by default. And also show local variable type ints. I usually configure these two ones. And that's pretty useful because with that kind of configuration, you get the best of the two worlds. You have the return types, which is explicitly displayed, but you'll still leverage Kotlin type inference to infer it. Yeah, that's pretty useful, I think. I'm using @REST controller, @request mapping, @get mapping. It's basically, if I had a Spring MVC code, it would be that without the suspend keyword. Okay. You notice that if my handler method is not suspending, here I have an error because suspend function delete should be called only from a coroutines or another suspending function. And that's what I meant when I said that coroutines color the API. It's that you can call, it seems a little bit magical because you don't have to use these reactive wrappers, but it really improves the readability, I think, of the code. But it's not magical, and things has to be explicit. And a non-suspending function can't call a suspending function. It's possible, so there is some capabilities to call that into lambda parameter, but basically the rule is that you need to call suspending function from another suspending function. And in terms of characteristic, it will be almost the same than if you were using Reactor, Flux, or Mono. It's all reactive underneath. We have also this controller support. So here, I'm writing my HTML controller, I'm inject user repository, and I'm using the model to add my users, and I return the name of the view. Notice that here, for model, so model, you have add attributes, but you don't have this kind of bracket notation, which is specific to Kotlin. So here, we are using a Kotlin extension that it's an extension of type operator. So basically, it defines the set operator on model to be able to make it possible for us to use this nice notation instead of add attribute that makes the code more idiomatic. We have our template. So this is a mustache template. You can use Teamleaf if you prefer it. And I will just display some HTML, and I will display dynamically, but on server side, the list of the users. And I have my tests. So this is the basic one, which is generated by default, and this one is more interesting. I'm building a test. So with Spring MVC, you would have used mock MVC, for example, to test that in a more efficient way. Here we are using Web Test Client, which is a test API similar to WebClient. So we are going to test our user API. So we are using this client, and we basically define what we expect. So here we are requesting the /user/endpoint, and we expect a body list with these users. Like I said, since I can't call suspending function from regular function, I need to use this run blocking facility, which is like .block with a Reactor API. And since we are in test, that's perfectly fine to use this kind of statement. Maybe later there will be native support. Maybe there will be some JUnit extension that natively supports suspending function, but that's not yet the case. So we have to do that. Okay, I think we have find one user. We have the other one. That's the same thing. And here I'm creating some user in the repository. I delete it via the API, and I check on the repository that it has been deleted. So if I run this test, unless the demo effect, it should be green. Okay. So we are fine. We have this. If I run the application, okay, so we have these users are coming from the database, and after I will add dynamically elements in the DOM with the Kotlin.js frontend. But for now, we are fine. So I'm going to go step 2. Here, I have chosen to use exactly the same annotation you would use with this is the at controller at get mapping level. Okay, so every route is defined with annotation. But like I said previously, with WebFlux, I have the possibility to use the routing DSL with the functional API. So I will do that change with this new branch. And instead of using, so the rest of the application is the same, okay? So our user repository is the same. But here, we are going to use the DSL to define the routes. So I create a router configuration to expose my router function bin. I'm creating the DSL with the co-router. So router is for Reactive API. So if I write router, here, it will still return a router function, but if you have a look here, I'm using I'm using mono of server response. Okay, so this is the DSL you will use if you are using Flux and monos. But here we are going to use the same infrastructure, but with coroutine API. So we are going to use instead this co-router API, which is exactly the same, but the signature that we are using here is the signature that we are using here is a suspending function that take a server request parameter and return a server response return value. So here I have, with the autocomplete, I have access to the various HTTP methods. Okay, I can define some request predicates using some specific media type. I can even define some filters that are applied after or before the elements. I can create some request predicates based on customized headers, and you can also create your own request predicates. And you can combine them. So you can, for example, you can create get /foo, and you can combine it with other thing like that. Okay, and then you write what it return, body, etc. So you can really combine everything. No, not body, body and await, because we are using the functional version. So you can nest the predicates. So here we are going to prefix the request predicates with /user. So every request that starts by /user, /login, or everything which is included, these two nested predicates will be combined, and you can nest any number of predicates that you want. This is callable references, so I could directly write my implementation here, but here I'm choose to externalize the implementation of the handler outside, typically in an handler that will have injected the repository or the service that I'm using. And here you see I have a suspending function that takes a server request and return a server response. And I'm using server response dot. So here I specify the HTTP status. Then I have access to various methods. So body is like returning something, returning an object in the annotation-based programming model. Here I'm choose to render a view, so I will specify the name of the view, and I add the data that are used to modify dynamically my template by creating a map. So this is a way to create a map in an idiomatic way in Kotlin. If I go to my user handler, it's still a component. We inject the user repository, and I have the same kind of pattern with my request as input parameter, and I return a server response. And here, I'm using body and await. Okay, so body are the methods that are originally available in server response, and they return mono or fluxes. And body and await, it's the suspending function. So it's an extension that just convert that into something which use suspending functions. Here, what we are doing here. So what is interesting is that with coroutines, we are using exceptions like we use them in blocking world, in imperative world. This is not like in reactive world where it's a little bit different. So here we are just calling find1 on the repository. You see find1 return a new label user. And like I said, null safety is natively managed by Kotlin. So if I just do that, it will return a non-nullable user, which is not what I want. What I want is that it return a user or it throw an error. So what I need to do is to use this question mark dot let notation that will basically, it's like dot map. It will change, it will modify the return value if what is returned here is not null. Okay, so if a user is returned, I'm answering an OK status code and I specify the return value as the body value using the coroutines extensions. And if no user is returned, I will return a not found answer, and in that case, I will have the expected behavior, return a user in JSON or throw a not found error status code. Here's the same thing. I'm transforming the returned value to just a server response. If I want to specify the status code, I have an API to do that. Okay, so I'm just using status, and I specify HTTP status.created, and that's it. We are now going to step 3. So we are going to introduce RSocket support. So here, in addition to our backend module, which is, again, a Spring Boot application with RSocket. Now we have added the RSocket for the RSocket client. Mustache, WebFlux, Spring Boot starter data, R2DBC. I have a bot module. The purpose of this module is to create a very, very simple bot that will answer something when we get an answer. And like I showed previously, it will discuss with the backend with RSocket. So to do that, I'm adding the Spring Boot starter RSocket dependency. And I'm going to, using the same message class. I could have created a shared module, but I will do that in the next step. The interesting bits are in bot controller. So here we have a controller annotated with @controller, like your REST endpoints. But instead of using @request mapping or @get mapping, I'm using @message mapping, which is basically the way where we expose server-side endpoints for RSocket. So in terms of implementation, it supports Flow, it supports Mono, it supports Flux, so you can, it's flexible method signature like with Spring WebFlux world. So here, in terms of discussion pattern, we are using a flow of messages as input and a flow of messages as output. And here, this is a very crappy implementation that will just return is it me you're looking for if the message in input is hello. So, and we have also another channel, which is a broadcast one. So this one takes nothing as input and will just return a stream of service messages. Okay, very crappy implementation, but that's just to show you a simple example. We could also use a suspending function if I just want to just return a value, and everything is using back pressure over the network when you are doing that. In terms of configuration here, so Spring Boot has built-in RSocket support. So here I can specify what kind of transport I want to use. So here I'm using TCP, I could use WebSocket, I specify the port, I specify also the logging here because I would like to log the various messages exchange. And on, we have also the tests. So in terms of tests, we are going to use the RSocket requester, which is the equivalent for RSocket compared to WebClient in the HTTP world. We are going to inject the local RSocket server port via Spring Boot. And here I'm using the API. So basically I inject not directly a RSocket requester, but a builder of RSocket requester. I specify what kind of MIME type I would like to use. And if with HTTP endpoint, usually you use JSON. Here we are using to use CBOR. CBOR is a binary format. And usually when you do RSocket communication via TCP between two server-side microservices, it's better to use a binary format that will be more efficient. So for now, we have support for so JSON, which is not binary, but we support obviously JSON because it is ubiquitous. We have support for CBOR and I think we have support also for other media type, but I don't remember exactly what are the other protobuf. I think we have support for protobuf as well. Originally, there is connect_TCP method that return. I can show you with the autocompletes. Connect_TCP will return a mono of RSocket requester, but here we are using the coroutine extensions. So connect_TCP and await. And that allows us to deal with that in a very imperative way. And then we specify that we want to request the root bot.messages, which match with what we have defined here. Okay. We send the data. We create a sample message, hello, in order to be able to have the famous answer of Lionel Richie. And we assert that we get this answer. And we also check that if we send a message which is not hello, Lionel will say nothing. Okay. Then we have also updated the backend side. So here we are going to use the RSocket requester builder, okay, to create a new RSocket requester, and then in this so this endpoint will produce a stream, okay. So it will basically produce a stream which will be exposed via server sent events. So let me start by the right parts. So /messages/stream, we expose with text event stream, which is a server sent event media type. We expose a stream that will be consumed on the front end, and the implementation is that we are so you see OK.ssc, that's a shortcut to specify that we are using the server sent event media type. And then we provide a body of type flow. So we are providing a flow of messages. And this flow of messages is emitting, it merges three things: the replies from the bots, the message sent by the front end via the posts. You see here, we have a post endpoint that allow the front end to send of messages. Okay. Joke. And we also get the broadcast messages sent by our bot here. Okay. And we merge these three things, and we provide it to the front end via server sent events. If I was using If I was using Socket.js, RSocket JavaScript support, I will not use server sent event support of WebFlux, but I will just use RSocket client to provide the data stream via a WebSocket connection to the front end. But here, like I said, I'm just using server sent events. And I think we are fine. Okay. So now we are going to go step 4, and we are going to use Kotlin on the front end. Like I said, you can totally use that with TypeScript, using Socket.js, etc. But here we want to have a little bit of fun, and I would like to show you that one of the interests of Kotlin, even if that will be maybe more important on the long term than today, is to be able to share some codes between various type of runtime, and that could be between the front end and the back end. So here we have our Spring Messenger multi-module project. Let me just update the Gradle configuration. And we have various modules. Better. So we have the backend and the bot. This is the same, and we have front end and shared. So shared is a multi-platform module. So here I'm using. Choke, maybe better for you. I'm using the multi-platform Kotlin module. Then I'm defining that I'm enabling the JVM and the JavaScript platform for the browser. I could also target Node.js here. Okay, I can also target Node.js and create some code that run into Node.js on server side. I'm specifying the dependencies. And then in my common code, I have message and user. And I have even shared tests. And the IDE integration is not finished, so it does not work in the IDE. But if I do, so if I'm going to the command line, okay, if I'm doing front-end test, okay, so I don't have any output, but the tests are run, you can believe me. So that's it. To be totally honest, here I'm using a simple case where I'm using just string. If I have some more complex type like datetime and things like that to be shared between JavaScript and frontend, this is a little bit more complex. So there is some support for multi-platform types that can be shared between frontend and backend. But here, for the sake of simplicity, I will just use string. But there is some project with some multi-platform data types. So in backend and bots, you will see that I don't have anymore any model. I'm just defining a dependency here in my Gradle build file towards a shared dependency. And for bots, this is the same. I don't have any more any model class here. Now let's see the front end, which is this project. So in terms of build file, I'm using Kotlin.js plugin. Okay. I'm also applying Kotlin DCE.js. So DCE is the plugin that remove unused code from the front end, because otherwise the generated JavaScript is so huge that your browser will die. I mean, it will work, but you won't deploy that in production, believe me. So yeah, this plugin is to get quite concise JavaScript code by default. Then I'm defining the module kind. So here I'm using UMD because I want this to be usable in the browser in addition to Node.js. And I'm defining a Webpack task. So underneath, it's using Webpack, but you don't have to configure it yourself, because usually, especially as a backend developer, you don't want to pay the price to configure the complex JavaScript stack. So it's possible if you want to configure directly Webpack and run it from Gradle. It's totally possible, but by default, it's hidden underneath. On our front end, we are using stdlib-js, and we are also using the coroutines dependency. So coroutines, flow, suspending function are a multi-platform library that is available for the JVM, but that's also available for native if you want to develop an iOS application, or available for Kotlin.js if you are developing a front-end application. And the great interest of that is that you can use the same API, leverage the same knowledge, and you can use the multi-platform module of your own application. So here, thanks to this dependency, I will be able to use message and user in my front-end code, and this is the same code, so no synchronization problem with both. Now, in terms of code, so I'm developing the front-end with Kotlin. The great thing is that I have access to all the features that Kotlin provides, like extensions, things like that. And here is the main. So this main will be executed when the browser is launched. Okay, when my web page will be available, and you have this document object available with various capabilities that are statically typed. Again, I want to be fully honest. The API exposed by Kotlin.js is not perfect yet. It does not look like idiomatic Kotlin everywhere, but that's a pretty good start. It's similar to what TypeScript provides, but I really think that Kotlin.js could do a better job. Like here, I have to cast it, because basically they automatically generate Kotlin binding for the DOM and the web APIs. So they did their best like that. So here we get the user select, the message input, the submit button, DOM elements, and then we define some callbacks. So when we press enter, and if the field is valid, I will submit a message and send it to the backend. I will reset the value and things like that. Same thing is I clicked on the submit button. And then I will do something because I want to show you how we can use Flow in the browser. There is no API based on Flow by default, but I can write an extension because I am on the front end. So I can add a asFlow method on the event source. Event source is generated. So this is the JavaScript event source type, okay, directly created from the DOM and the web APIs. And here I'm using callback flow, which allow me to convert basically a callback-based API, which will receive multiple messages and expose it as a flow or something. So I define this extension, and then in my code, I can write, so event source, I specify the URL, which is the same one I expose in my backend. I convert it to flow, because here, I convert it to flow. I use .map, so I transform the object, which is just plain text with the JSON. I parse the JSON and I transform it to a message. And then I trigger the collection of the flow, and I adding some DOM elements into the right DOM elements. And when I click on the submit button, I will use the fetch API, which is a modern API available from the browser, and it has a Kotlin.js binding. I specify the URL to it. I define that that's a post. I define the content type and the body. I serialize the message to a JSON. Okay, and then I define the dependency in my backend. So my backend, it has not been updated. Not sure why. My backend should have a dependency on. Let me check. No. Okay, it is here. It is specified via a specific task on the process resource side, and basically I depend on the front-end browser webpack task, and I copy the output from build/kotlin.js/main to the static repository, the static directory, which is automatically exposed by Spring Boot. And by doing that, I will run my application. So I go to my backend. In recent version of IntelliJ IDE, every operation, every Gradle task are natively based on the Gradle operation, so it will automatically deal with the Kotlin front-end part. I also run the bot. Okay, so here I receive my service message. I will open two tabs. Okay, and here, if I send some message, it is written here. Everybody is receiving the service message sent by the RSocket bot. And if I tap hello, this is the most impressive part of my demo. I know it's not awesome, but Lionel is answering me, and I felt not alone anymore. Okay, so now, and if you go to the bot, you will see the various RSocket frames that are displayed. Here I'm using a binary CBOR format, so you can see everything, but you can use JSON or other text-based format to be able to debug things if you need to. I'm going to finish that with converting the application to use Kofu. So I have created this Spring Flow project last year. The purpose of this project is to be able to basically configure your Spring Boot application with a DSL. Spring Boot is natively built for Java, and it's using a set of clever conventions to be able to configure your application. These conventions are, for example, that when you have the Jackson dependency on the class path, it will automatically configure the Jackson converters and codec as needed. That's super useful, but with Kotlin, we can configure everything explicitly. And that's great because configuring things explicitly means less work to do at the startup, so it starts faster, it consumes less memory, and you don't have any surprise because if you have a feature, you have asked this feature, it's not something that will pop up because you have added a dependency. This dependency could be a transitive dependency, so that could be a total surprise. So you are in control to configure everything with this application root DSL, which is a kind of mother of all other DSLs, and this DSL is leveraging the other ones, beans, router, etc. Okay, so this is an experimental project, which is in Spring Project Experimental, and so I have stopped that. Okay, so I switch to the last part. I import the changes, and here I have converted the backend project into an application configured with Kofu. So to configure an application with Kofu, you have to add the Kofu dependency, which will provide this application DSL. And if we are going to the backend application, we have still the main, okay, but here instead of using the annotation, I'm defining an application of type reactive. There is also support for Spring MVC with the servlet thing. And we are basically allowing to configure your application, your Spring Boot application, in a modular way by defining configuration slices. So here I have 3 configuration slices: data config, web config, and RSocket config. And you see here I can define any kind of configuration, so I can create some bins, and these bins will be automatically auto-wired, so I don't have to inject manually all the parameters. I can define listeners. I can enable here the R2DBC support. You can also configure logging. So for example, if I want to configure logging, I'm using that. Since I'm lazy, I will just have to follow the autocomplete to configure everything. I don't have to go to the reference documentation, find the right parameter, etc. And I'm just leveraging the capabilities of my IDE to do that. Again, by default, you will just use Jackson, and you will want to enable pretty print, for example, to have something that displays nice. So here you have access to all the Spring Boot capabilities to configure Jackson in a discoverable way, and you can find, okay, this is indent output I want, and you write it. So everything is discoverable. In my web config, I define the bins that are used to implement the web part. So here, there is support for creating a bins directly with a top-level function reference, and every input parameter will be injected. I'm defining the bins for the handlers as well. I enable WebFlux. Configuration is explicit, so I have to explicitly say that I want Jackson. Okay, it will not be enabled by default because Jackson is in the class path. I also define explicit configuration for Mustache, and for RSocket, I'm just creating a bin of type RSocket builder, and I configure it with Cbor. And this application can be run. It's a Spring Boot application, okay. But configured in an explicit way. So I need to run the bot application. So I run the bot application, I run this one, Not sure if that works or not. Okay. Yeah, because I have set the log level to error. That's why. And my application is working as expected. So this is something that is not yet production ready. I mean Kofu. So it's still in experimental mode, and I will continue to improve it. My goal is to get that integrated in Spring Boot as a Spring Boot application DSL, but there is still a long way, so I need to make progress on that. Okay, so like I said previously, so this was the Spring Messenger demo. The ideal architecture would be to use RSocket for the client as well. So it's possible to use RSocket.js for the front end, and also to use RSocket on Android, because there is an Android. I mean, the JVM RSocket client can be used on server side and on Android side. Currently, it only exposes a Reactive API with Flux and Mono, but it should be easy to define some extensions to convert it in coroutines, and I think that will be done shortly. So if you want to have a look to RSocket.js, there is this project, and you can use it on front end. Like I said, it's a little bit young because metadata extension has just been integrated. Also, it's using Flow from Facebook and not TypeScript. So there is maybe a need for TypeScript definitions to be to make that easily usable on front end. Hopefully, that will mature a little bit and it will be available. And I have created this silly issue about. So there is a RSocket Kotlin project, because until recently it was difficult to use Java 8 based code on Android. Nowadays it's more and more easy. So I think the RSocket Java client could be used directly on Android. So there was some discussion about just shutting down RSocket Kotlin, which is based on Kotlin JVM. And the idea I had was to propose a reboot of RSocket Kotlin as a multi-platform library. So the idea would be to expose the Coroutines API for all platforms, Kotlin JVM, Kotlin Android, Kotlin JS, Kotlin Native, that will implement RSocket protocol, which is just a protocol with a specification that can be implemented with any kind of API. Reactor or any reactive streams API are a good choice, but you can also expose it with Coroutines and Flow. And yeah, some people are excited about that. Obviously, that's a big work, but that's maybe an idea for the future. And I think that's a good use case for Kotlin multi-platform capabilities to be able to provide for all platforms with the same API access to this great RSocket protocol. Thank you for your attention. I will make the Spring Messenger project public just in a few minutes, so you will be able to have a look to the source code. You will be able to check out the various branches, and I will update it. So, for example, I think in the future I will replace the server-sent events communication by RSocket communication for the front end. You can follow me on Deleuze on Twitter, and if you have some questions, I can answer them. Thanks. Some questions? Yeah?
What's the add flow preview annotation you used?
The
add flow preview?
Add flow preview is because flow is a very recent type, and it has been made non-experimental very recently. So flow by itself, it's not experimental anymore, and you can use it without expecting some API changes. But some operators, which are specific extensions, are in preview mode. Okay, so that means that when there is this annotation, it's just to avoid some warning in the IDE. Flow preview is to avoid some warning in the IDE because I'm using some specific operators which is not stable yet, and the API could change basically. Yeah.
I noticed that in the repositories you use the raw SQL statements.
I'm using what kind of statement? Could you repeat?
RoSQL statements, RoSQL without type safe.
Yeah. So the philosophy of the Spring Data R2DBC is indeed to just provide you a way to write the SQL request with text, so in a non-type safe way. It will be type safe in terms of object mapping, but indeed, when you write the SQL request, it's not type safe, and that's where I think the support from other kind of clients could be like Juke, for example. It's not yet available, but I think there is some early preview of reactive support in Juke. So other kind of clients should be able to support R2DBC underneath and exposing it as with a type-safe API. There is also some Kotlin API like exposed, which is basically writing SQL request in a type-safe way using all the Kotlin capabilities. And exposed is a very interesting library. So maybe this kind of library will support R2DBC underneath. And that's my hope, is to see, I mean, Spring Data R2DBC is a way to consume your reactive SQL database. But like I said previously, we expect other kind of SQL clients with hopefully type-safe SQL API to be supported in the future. But that's all new, so we need to wait the ecosystem leverage that. Okay, thank you. Last question, yeah?
Maybe one question on the Kotlin functions. Basically, it seems that you are saying that everything needs to be explicitly configured. Doesn't it go against the basic philosophy of Spring Boot, where you basically have convenience over configuration?
Okay, so. No, okay. So the question is, yeah, that the explicit configuration shown in the Kofu DSL is going a little bit against Spring Boot philosophy of configuring everything with conventions. And indeed, that's reusing some part of Spring Boot, but indeed the philosophy is different. So is it Spring Boot or is it something different? That's why this is a separated experimental project. But it's leveraging all the capabilities of Spring Boot to configure all the JVM ecosystem, because Spring Boot is really the integration point of the JVM ecosystem. But indeed, the DSL approach is significantly different in the fact that it's a different way of configuring your application, and everything is specified explicitly, so it's just different. My gut feeling is that for Java, configuration, implicit configuration via convention is the right thing to do, and that's why Spring Boot is super successful. This is because Java is not advanced enough to be able to do explicit configuration with the concise code, readable code, etc. And at some point, I tried to create Jafu, which was a Java DSL to configure Spring Boot explicitly. And even if some people are crying in the Spring Foo issue tracker, I killed it, and I won't respawn it, because I really think that the noise in terms of code, it's just not doable. It's not maintainable, and I don't want to go that way. So I think this is another philosophy to configure Spring Boot, possible because Kotlin allows to write DSL like that, with autocomplete, with very readable code. And it's not possible to do that in Java. So since Spring Boot is coming from the Java world, it's perfectly fine to do that in Java. It's also perfectly fine to do that in Kotlin. I mean, that's what you should do if you are writing today an application with Spring Boot and Kotlin, and that's perfectly fine. But I think this kind of DSL, like Kofu, allow to leverage even more Kotlin to provide not just you write exactly the same application with a different language, which is fine, but not enough, in my opinion, to really trigger a wide move toward Kotlin, but you really leverage and embrace the philosophy of Kotlin to give you additional advantages, like I shown. Everything you define is explicit. The code is still readable. I have not shown everybody, but you can define your application. You can define your slices of configuration in a very fine-grained manner, and in your integration, in your integration tests, you will just enable the slice that you want. With Spring Boot regular code, there is predefined slices like the data one, the web one, but usually, and that's a very common problem, people complain because too much is run and their application integration tests are slower. With this kind of approach, where you are in charge of defining your own configuration slices, you have the control to define only the right slice for your code, your integration test, mocking just some part, and you have more control on everything. Okay, thank you.